Now that I've got all this recorded, I'll just
sweet.
this in. Oh, Lord. All right, here we go. Hello, and welcome to another episode of Intune.training, the place to learn how to use Microsoft Intune. The Steve and Adam Show with Ben,
Hi, Adam.
Steve, and Jake, and we got this other guy over here, Nick Hogarth. Hey, Nick.
How are you?
So you may recognize the name if you've been on the social medias and the Twitters and forums and things. Nick is a Microsoft MVP based out of Down Under Land over with Steve and Ben. And he's joined us tonight because he's got an issue and that apparently only Ben can solve. And so guys, take it away. Tell us what's going on.
Sweet. Yeah, so Nick, did you just want to have a brief description of what the problem is?
Yeah, so I'm just looking for your advice on the best way to deploy registry keys. So for the HK key current user and HK local machine, how you would tackle that? Because I always get that question on the forums of people having issues. So
yeah, so it is a common pain point. So obviously the current user registry is technically it's available to the end user to modify, unless you really restrict that down. But I believe it's editable by standard users. But a lot of people do tend to want to have, if they've got bulk, let's say groups of policies that they want to apply to their registry, they want to do the HK local machine and the HK current user stuff all in one script. They just want one thing that they want that they can manage. So years and years and years ago, after Steve promised something that maybe didn't exist, and I had to desperately figure out how to do it, I came up with a solution that I used in pretty much every client that I then ended up sort of doing work for. So I sent this to Nick the other night, and he was just like, "Okay, but explain it to me." So let's just do that now, and I'll show you sort of how I would actually deploy this now if I had to do this.
I think the other thing that he actually said there, Ben, was that you had a typo in your code.
He did. Yeah. That's great. So
possible typo.
Sorry to whoever the client was that I deployed this to. I'm no longer a consultant. But
you can find the updated copy on
exactly. Yeah. Also, fair call. I am going to put this stuff up on the Intune training repo, so we'll have a link down below for all that information. All right, so I'll just really quickly jump through the code. This isn't the point of the thing, but so I've broken everything down into sort of the big chunks. So we've got some configuration info because I like to put logs and stuff for these scripts so that we can troubleshoot them or actually verify that they ran on a machine. So we've got the name of the script. It's just HKCU scripts. Our client is Nick Corp. I'm going to dump the logs into this path, and I'm going to make a log file that is just going to be HKCU scripts. The real magic of this is a function that I did not write, and if I can remember where I got it from, I'll also put a link down below for that. But this is just a set registry value for all users, specifically the HKCU registry hives. So what we're essentially going to be doing is we're going to grab a whole bunch of the different registry keys that we want to apply to these users. We're just going to throw them at this function. It's going to do the work for us so that we don't have to worry about it. The function itself is very simple. It just goes through every single potentially logged on user and applies that key, and then also does something that Adam doesn't like, and it puts the policy into a unique entry in a thing called active setup, which Adam just told me is no longer supported, but it's still
just stop putting words.
Anyway.
No. Just let me, since you drug me into it. Just take a moment.
Okay.
Active setup exists and it works, and people have been using it for forever. But apparently, even back in there's an article from 2011 that we'll post in the deal. That this has never been supported. It was never supposed to be publicly used and exploited and whatever. And in fact, anything you write here doesn't get upgraded whenever you do feature updates. So these keys don't migrate with you. So there is a risk if you're depending on these things that they won't work properly at some point. But whatever, they work now. Use them.
So the point of the active setup thing is essentially so that if someone jumps onto a machine for the first time, then this active setup will actually apply these keys to their profile without having to have the policy downloaded and run on their profile. The point is that we're going to be running the script as system, not as the user. So potentially it's not going to run again if it's already passed. So this sort of gets us around that. But also at the end of the day, if we're doing feature updates and if we set up our detection methods correctly, if this doesn't exist, it's just going to reapply. So I'm not super concerned about that, but it is a fair thing to call out that active setup isn't supported. But it does work for the scenario that we've got.
And then before you keep going down, go back up to so you mentioned that you're looping through, keep going back up to the logged on user SIDS. So in this case, you're talking about, so you said logged on users. So these are hives that are already going to be loaded into the registry under HKey users, and you can hit all of those because they're already loaded. Are you doing anything to load hives that exist on the machine and inject this for users who aren't currently logged on the machine, or are you just getting logged on users at this point?
At this point, we're just getting logged on users. So it's fair to point out that this was written for almost all of the projects I did were greenfield, so they were brand new machines. So these policies were applying to essentially freshly built machines. So I didn't particularly care or assume that there was going to be 4 or 5 users at a machine at any given time. This was to apply initially, and then any other user that jumped on would get it through the active setup. So there's 100% a way to do this to load those unloaded hives, but it was not necessary for this because of that limitation or that assumption of how the devices were going to be used.
That's good for new devices built through autopilot and whatnot.
Yes, 100%.
Get all the keys ready, so once it's given to the user, it's all set up.
That's right. Yeah.
Exactly.
Cool. Okay. So the function is kind of the secret sauce of this whole thing, but let's not dive too far into it. I've got a little bit of logging. I'm just doing start transcripts so that I can analyze what the code is doing, and then we've got the actual configuration of what we're going to be doing. So it's broken up into 2 things. So we've got the HKCU region, which is just all of our keys that we're going to apply. So each key has to have a unique GUID. This is specifically for active setup. So the way that I showed Nick is that you can either generate these randomly each time it runs just by doing new -GUID, or just generate the keys and hard code them in. The benefit of hard coding them in is that you can use these for detection methods. So you can actually iterate through and just make sure that all of these policies have actually applied. The benefit of doing the GUID one is that I don't care, just make it work. So we've got the name of the key, the type of it, the value, and the path software properties. So we've got 2 here. And then similarly for the local machine hive, you just noticed what I wrote? It gets better. And then for HKLM, I've got exactly the same thing. We're just going to go into the local machine hive and create a folder called secrets, property C, DWord, value, all that sort of fun stuff. So these are very, very similar in sort of design. The real only difference is that we have a GUID for the HKCU, which is for the active setup stuff. So once we've got these arrays of objects, and again, this is the only thing that you, Nick, will be modifying. So you'll be specifically just filling this up with an object in that array for each property that you want to put into the registry. And then we go through and we process these things. So the HKCU step here. So this is all in a try statement. So if it ever fails, it's going to fail and tell us that it's failed in the portal. But the HKCU stuff is really small because we're using that function to do all the work. So if we have anything in that HKCU keys, we're going to step through each of those keys, and we're just going to run that function. So set registry values for all users. Registry instance is HKCU keys. This should actually be a key. Let's do that. The function actually works if you send a big array of things. So whatever. So yep, that's done. And then the next one is HK local machine. So again, we're just stepping through each key in the HKLM keys. And you can obviously see at one point I did this for time zone, which is hilarious. Setting update in registry. So we're basically just doing this thing. This is something that I also showed you, Nick, maybe last week. So we've just first of all got to verify that the key exists or not. If it doesn't exist, we need to create it. Otherwise, it'll fail. You can't sort of do a recursive property into a path that doesn't exist. So we just create that. If it already exists, we're just saying, yep, it's already found. Let's create that item property. So That stub is used. I used to use this all the time when I was creating local machine things. And then finally, we just wrap up. So we handle any errors. We stop the transcript as either a failure or as a successful. And this is important for the way that we're actually going to deploy the script. So the script is done. We've configured it exactly how we want. So now we need to deploy it through Intune. Now, there's a couple of ways you can do this. 3 come to mind. First one, the most kludgiest way, is bundle this up as a Win32 application and deploy it out that way with your detection methods and all that sort of fun stuff. The other one is just to do just a bog standard script deployment. But the one that I really want to focus on is the way that I would be doing this now if I was still doing this. And that would be specifically to create a proactive remediation script, which should be the standard if you're deploying PowerShell scripts to people. And I'm assuming Jake agrees with me here.
100%.
Sweet. Okay, so we're going to go into reports.
Check is in the mail.
Exactly. We're going to go into
endpoint analytics. It is buried in a strange place.
It really is.
Proactive remediations.
Yep.
Sweet. And then we're just going to create a new script package. Name is going to be Nick's Magic Script.
Hey, hang on, Ben.
Sounds good.
It's not quite right, because we need to have some emoji so it sits at the top as well, remember?
Oh, yeah, sorry.
We spoke about this?
No, we did.
He never remembers.
What's my emoji? That one.
Yeah, that's a good one. Money.
Exactly. Cool. And then we're going to go through, we're going to find, so this is interesting. So proactive remediation script is technically, we've talked about this before, but there's 2 parts to a remediation script. One is the detection method, one is the remediation. In this scenario, I don't want to remediate. You could probably break this up into 2 scripts and, if the key exists, then do the thing. But we're just going to do this as a single detection method script. And
that's where having that registered GUID rather than a randomly generated GUID is going to save you. Because
exactly.
Sit there and have that
then
remediation.
You want to
go and create it during
script.
a future update.
This one?
Because you edited the keys thing and you didn't save it.
I did. Let me bring that
also, on the basics, is the script publisher name, is that new?
No, it's always been there.
Oh,
no, it's been there.
Okay.
So it just grabs whoever's logged in and just pre-fills that. It's interesting. So what we're doing here is, we're just going to do the detection method script. And if you have logic in this script to, you need to come up with your own detection method script logic here. What we're essentially going to rely on is if it fails, it's not detected. And if it passes, then it has detected. So it's not a very elegant solution for this sort of scenario, but it will still work. And again, so we're not doing remediation script. We're going to say that we want this to run a system. We're going to not enforce script signature checked, and we are always going to set this as 64-bit PowerShell. We're not going to set any scopes. We're not going to do any assignments for the moment. We're going to hit next, and that is it. This is now a proactive remediation script that will deploy out, will apply any of your HKCU keys to all of your devices that you assign it to, as well as any of your HKLM keys. Relatively simple. The real secret sauce again is in that function that I've been using for years. So Nick, that is how you would do that. We'll put the code up in a description below on the GitHub repo. Do you have any questions?
What was that detection script? Is that like a yes or no, or are you going to actually look for each key, or did you say just make it really basic? Like
in this scenario, because we're doing this real quick and dirty, we're essentially working on it's a Boolean value, right? So if any of this fails, it's going to catch that error. It's going to put the error in a variable, and then we're going to check. So if we've got an error, then we're going to write a warning. We're going to stop the logging, and then we're going to throw. So that essentially sends a non-zero exit code that Intune then captures and says the detection method failed. We'll actually get this error occurred message sent back to the Intune portal as a thing that we can actually report on, which is really cool. And that's one of the key benefits of proactive remediations.
Yep.
But then if it passes, it's just going to pass with a like an exit 0 code, which means it's all good. So we're not going to get the value. We're not actually checking to see whether the key's applied or not, but we can do that. What I would suggest is if you were to use this exact piece of code right now in your production environment without reviewing it at all, I wouldn't do that at all.
You'd be an idiot.
You would be an idiot. What I would be checking, especially for the local user policies that we're applying, to make sure that the function ran, I would be checking against this specific path. So that GUID is for all the different HKCU policies that you're applying. If that exists, then the script ran and we can claim that as a pass detection. So that's, that would be like an extra 5 minutes of writing the detection method and testing it. But this is going to be good enough to validate that it's going to work for you. And then you can sort of make it a little more advanced.
Yep, sounds good.
So Ben, I mean, you're using proactive remediations kind of halfway in this.
Not the way it was intended.
Not the way it's intended.
Yeah.
And obviously there could be more code put into this to make it work in that framework the way it was designed. The reason you're using proactive remediations to trigger this is because it's just a more robust way to run PowerShell scripts than the out-of-box or the other PowerShell scripts function.
It'll actually run on a schedule as a.
Well, yeah. So there's
more functionality. You're just not putting the complexity into your scripting for this use case.
Exactly. So there's two primary reasons that I will always sort of champion proactive remediations over just standard script deployment. The first one is kind of what Jake was saying, that you can actually schedule this to run on a timed deployment. So you can make it run every hour if you want to, which is another benefit over standard script deployment, where if that script runs, if you deploy this as a standard script and it runs once, we've talked about this previously, it's never going to run again unless you go into the registry and delete the proof that it ran.
Or you make a change to it.
Or a change, yeah.
Oh, yeah, the revision version. Yeah, for sure.
For this particular script, it doesn't really matter too much, though, does it? Like, you only wanted to run once.
It doesn't, but if you put in more advanced detection method logic, then you can potentially want to have this running every hour or so just to make sure that it still exists. And in the scenario that Adam
properly set, yeah,
exactly. So you can make this really, really resilient and really like solid, so that you just install it in an environment and know that those policies are always going to be there. Is one way to sort of look at this. The other real huge benefit of remediation scripts is that the input and output of the PowerShell script that runs goes back to the portal, whereas that information doesn't happen in a normal PowerShell script. So you
Which
can
is now
actually
exportable as well.
Yes. Yeah, for sure. So like you can actually get really, really smart with your scripts. So you can actually start pulling back data about an environment of a computer if you wanted to, even if it successfully passes. So you can potentially use this to pull back some, like, if you wanted to look at the environment path of a machine, or you wanted to do a really haphazard software inventory of a machine, you can potentially capture that data, send it back as your path value, and then you have a very kludgy, very non-standard software inventory solution that maybe is better than the default one that exists right now. Not suggesting that that's a good way to do it, but you could potentially.
There is a character limit on the amount of things you can return, though. It's a little over 2,000.
Yeah, that makes sense. It's very similar to the problems that we have at our job, Jake.
Ben, one last piece. So in your script, I noticed that you have variables at the top, but then later you have variables that you've got to go set for the HKCU and HKLM. Why wouldn't you move those to the top so they're not embedded down in the script?
Because I wrote it for me.
Okay, just checking.
No, so the script itself comes from a template that pretty much all of the scripts that I wrote for customers sort of all look the same. You've got the configuration details about what it is and who it's for at the top, and then the business logic in the middle, basically. But yeah, it can be written nicer. But yeah,
good stuff.
Awesome. So hopefully, Nick, that helps you out.
That was good.
I think it's a very common problem that people have.
It is very common, not just myself. I see it on the forums all the time, so it'll help a lot of the people.
Awesome.
How to tackle it. That's
been
good. Thanks.
Sweet.
Awesome.
Excellent. Well, thanks for coming on, Nick, and bringing your problems with you, I guess.
Short notice.
What else are you going to do
Has
in
jumped
lockdown?
in. Oh yeah, it's raining outside and it's locked inside.
We just ambushed him, so it was fun. Anyway, thanks for coming on. We'd love to have you come back and hang out again.
Sure,
we always need some more Aussies. I always say that we need more Aussies on here.
Of course.
We need to outplay the Yanks.
Yeah. All right, boys.
There.
Good job, Ben.
Thanks, everyone.
Thanks, Adam. Talk to you guys
Bye.
later.
Cheers, everyone. Thanks.